Have you ever wondered what it would feel like if humanity was listening to a heartbeat from the dark, knowing any pulse could be the last? Because that is exactly where NASA is right now with Voyager 2, a spacecraft so far away that by the time Earth hears its voice, almost a full day has already passed. And before we go one light year deeper into this story, tap, like if space still gives you chills, subscribe if you love real science without the nonsense, and share this with one friend who still looks up at the night sky and feels something. What makes this moment so gripping is not just that Voyager 2 is old, it is that it is still doing something no other working machine built by human hands can do. It is still sending back direct measurements from beyond the edge of the sun's protective bubble. That alone would be historic. But the reason scientists keep paying close attention is even more powerful than that. The data Voyager 2 sent back did not simply confirm what researchers expected. In some key ways, it challenged their picture of the boundary around our solar system. And that is where this story becomes much bigger than a dying spacecraft. Because when a machine that launched in 1977 tells you your model of space may be too simple, you listen. Voyager 2 was never supposed to become this kind of legend. When it left Earth in August of 1977, it was designed for a mission that sounded ambitious for its time, but still temporary. Fly past the giant planets. Take measurements. Send back images. Expand human knowledge. Then, eventually, fade into history. No one on that launch day could have honestly expected people in the 2020s to still be waiting on its messages. Yet that is exactly what happened. Voyager 2 became the only spacecraft in history to visit Jupiter, Saturn, Uranus, and Neptune up close. It gave humanity our first real close view of Uranus. It gave us our first, and still only close flyby of Neptune. It found new moons, new rings, violent storms, strange magnetic behavior, and details that shaped planetary science for decades. Some of the images most people picture when they think of Neptune did not come from a modern probe. They came from this one aging explorer speeding through the outer solar system before many people watching this video were even born. That fact matters because Voyager 2 is not famous only for surviving a long time. It is famous because it keeps holding a kind of scientific monopoly. There are still things we know about Uranus and Neptune only because Voyager 2 was there. No follow-up mission has replaced that close-up record. And after finishing its grand tour of the giant planets, the spacecraft did not stop being useful. It just moved into a different chapter of history. Instead of circling back, Voyager 2 kept going. It moved past the outer planets, past Pluto's orbit, past the comfortable zone where the sun still feels like the center of everything. Out there, the solar system stops looking like a neat family of planets and starts looking more like a bubble moving through a vast ocean. That bubble is called the heliosphere. It is formed by the solar wind and the sun's magnetic field, and it acts like a protective shield, helping block a large amount of incoming cosmic radiation from the wider galaxy. For a long time, scientists could only estimate what that boundary might really be like. They had theories. They had models. They had indirect clues. But theory and contact are not the same thing. A coastline drawn on a map is not the same as standing with your feet in the water. Then Voyager 1 crossed into interstellar space in 2012, and Voyager 2 followed in 2018. That alone was incredible. But two crossings are far more valuable than one, because one event can always be a fluke, a local oddity, or a special case. Two separate crossings give scientists something much better: comparison. And comparison is where the surprises started to grow. Many people imagine the edge of the solar system as a clean line. One side is ours, the other side is interstellar space. But the readings from Voyager 2 suggested the picture is messier, stranger, and much more alive than that. Scientists expected major changes when the spacecraft crossed the heliopause, the boundary where the sun's outward influence gives way to the interstellar medium. They did see dramatic changes. The count of particles from our solar system dropped hard. Cosmic rays from outside rose sharply. That much signaled a real crossing. But the details did not line up in a neat and simple way. One surprise was that the plasma just outside the heliosphere looked compressed and a bit warmer than expected. That matters, because space is not empty in the way people casually imagine. It is filled with particles, fields, motion, pressure, and interactions that shape how energy travels. Voyager 2's data suggested that the region just outside our solar bubble was not a calm, untouched emptiness. It looked like a place under pressure, a place where the border between the sun's territory and interstellar space behaves less like a wall and more like a stressed, shifting frontier. Another surprise was that plasma density near the boundary showed signs of compression on the way out. Again, that may sound small until you understand what it means. Scientists were not just learning where the boundary is. They were learning that the boundary itself may be dynamic, squeezed, disturbed, and responsive to the sun's activity in ways that are still being worked out. And then came one of the strangest findings of all. The magnetic field just outside the heliopause appeared to line up in roughly the same direction as the magnetic field inside the heliosphere. That was deeply unexpected. Before Voyager reached these regions, many models suggested scientists would see a much clearer directional shift when leaving the Sun's magnetic domain. Instead, both Voyager 1 and Voyager 2 found something more confusing. The magnetic fields seemed aligned across the boundary. That is the kind of result scientists love and hate at the same time. They love it because nature has just told them something real. They hate it because reality has refused to behave cleanly. Suddenly, the boundary is not just a finish line, it is a puzzle. Voyager 2 added another twist. Its measurements suggested the heliosphere may be somewhat leaky. In plain English, particles from inside the solar bubble seem able to slip across that boundary into interstellar space. That means the edge of our solar system may be more porous than solid, more like a membrane than a shell, more like a living surface than a hard border. And that difference matters because it changes how scientists think about protection, radiation and pressure, and the way our star interacts with the galaxy around it. This is not a cosmetic update to a textbook diagram. It affects how we understand the sun's role as a shield and how the solar system breathes, expands, contracts, and exchanges energy with the wider Milky Way. Even more interesting, Voyager 2 did not cross at the same place or the same time in the solar cycle as Voyager 1. That gave researchers evidence that the heliopause is not fixed in one perfect shape. It likely shifts, it stretches, it responds to changing solar activity. NASA scientists have even compared this behavior to a lung expanding and contracting. So when Voyager 2 sent back its data, it was not just reporting from far away, it was revealing that the edge of our cosmic home may be moving, flexing, and behaving differently depending on where and when you meet it. If this kind of story makes your brain light up, pause for 2 seconds and join this channel. Hit subscribe, leave a comment with the word frontier, and send this video to someone who thinks space news is all hype. The real stuff is even better. Now here is where the emotional pressure of the story starts building. Voyager 2 is still making discoveries, but it is doing that while dying very slowly. Out where Voyager 2 is traveling, sunlight is too weak to be useful for solar panels. So the spacecraft runs on a radioisotope thermoelectric generator, a power system that turns heat from decaying plutonium into electricity. When Voyager launched, that system produced far more power than the spacecraft now has, but every year the energy budget drops. NASA says the probes lose about 4 watts of power annually. That may not sound dramatic in everyday life, but in deep space it is everything. A few watts can mean the difference between one more instrument operating in permanent silence. Imagine trying to run the last surviving research station in the most remote place anyone has ever reached, while the battery inside it gets weaker every single year and can never be recharged. That is the Voyager problem. For decades, engineers bought time by turning off systems the mission no longer needed. Cameras were shut down after the planetary flybys. Other hardware went quiet too. Those were painful choices, but manageable ones. The mission still had a future because the spacecraft still had enough electricity to power the instruments most valuable for studying the outer boundary of the heliosphere and the space beyond it. Now the easy decisions are gone. In October 2024, NASA shut down Voyager 2's plasma science instrument to save power. That instrument had become less useful in recent years because of the spacecraft's orientation relative to the way plasma flows in interstellar space, but it was still a symbolic loss. Then, in March 2025, NASA turned off Voyager 2's low-energy charged particle instrument, another move designed to stretch the mission's life. That left fewer instruments still active, but it bought more time for the ones scientists considered most important. And that is the cruel logic of this mission now. Nothing is failing because the team has stopped caring. Things are being switched off precisely because they care so much. Every shutdown is a sacrifice made to keep the spacecraft alive long enough to keep at least some science coming home. NASA has said that without these power-saving steps, the spacecraft might have had only a few more months before the mission faced a far more immediate end. Think about how serious that is. Not a few more years, a few more months. That tells you how thin the margin has become. Still, Voyager 2 is not dead. Not even close, in emotional terms. It still has a voice. It still has work to do. NASA expects it to keep operating at least one science instrument into the 2030s if things go well, although no one can promise that. Deep space is not gentle. Hardware that old is not predictable forever. There could be surprises, failures, or sudden silence. And that is what makes every update feel charged. Mission controllers are not talking to a healthy young probe with plenty of fuel and easy options. They are talking to a machine that has outlived generations, crossed into a region no replacement has reached, and keeps offering answers while forcing us to confront how little time may be left. There is also the sheer distance. Voyager 2 is more than 13 billion miles from Earth, over 21 billion kilometers away. Radio signals moving at the speed of light still take roughly 19 and a half hours to travel one way. So, when NASA sends a command, the team cannot sit back and watch an instant response. They wait, and then wait some more. Almost 2 days can pass before a command is sent, received, executed, and confirmed. That delay changes the emotional rhythm of everything. We live in a world of instant typing bubbles, instant loading bars, instant frustration. Voyager teaches a different kind of patience. You speak into the abyss, and the abyss answers tomorrow. Even that conversation is fragile. In 2023, a wrong command caused Voyager 2's antenna to tilt slightly away from Earth, interrupting communication. For a tense period, engineers had to work the problem from unimaginably far away. They could not reach out and fix a cable. They could only transmit a faint instruction across billions of kilometers and hope the spacecraft could still hear it. Eventually it did, and contact was restored. But the episode felt like a preview, a reminder that silence is not theoretical anymore. There's another piece of this story that deserves respect too. Voyager 2 does not whisper home on its own. Earth has to listen with some of the most sensitive radio antennas ever built. NASA's Deep Space Network uses giant dishes spread across the planet so that, as Earth turns, at least one major antenna can keep contact with the probe. In other words, this mission is not just a lonely spacecraft surviving in the dark. It is also an enormous act of attention back here on Earth. A machine. That old still matters enough for a civilization to keep listening. And what it is sending back is not random noise. The remaining science is focused on the environment around the spacecraft itself. Magnetic field readings tell scientists how the invisible structure of space behaves beyond the heliosphere. Plasma wave measurements help researchers infer conditions in the thin gas between stars. Particle data helps reveal how radiation from the sun and the galaxy shifts across the boundary. These are not flashy postcard images. They are something rarer at this distance. They are direct physical clues. That matters because without a spacecraft on location, much of this would remain an argument between models. Scientists could estimate, they could simulate, they could debate, but Voyager 2 can still do something more powerful than any of that. It can measure. And when you're dealing with the border between our star and the wider galaxy, one real measurement can matter more than 1,000 confident guesses. And still, in the middle of that vulnerability, Voyager 2 keeps doing something beautiful. It keeps helping us understand the shape of our place in the galaxy. Think about what the unexpected data really means. It means the boundary around our solar system is not a smooth shell we can summarize with one clean graphic. It may be compressed in places. It may be warmer than expected in key regions. It may allow particles to leak through. Its magnetic behavior may not follow the sharp directional break many models once predicted. And the area just beyond it may not even be undisturbed interstellar. Space, in the simple sense. Instead, Voyager data suggests a transitional region, a disturbed zone, a cosmic shoreline that is still reacting to the sun. That image is much more powerful than the old one. Not a border drawn with a ruler, but a frontier under stress. And maybe that is why this story lands so hard on a human level. Because Voyager 2 is showing us something that feels true far beyond astrophysics. The edges that look clear from a distance are often messy up close. The places where one world ends and another begins are rarely neat. They are full of tension, exchange, uncertainty, and change. Quick checkpoint before we cross even farther out. If you want more stories that feel like science fiction but are completely real, hit share right now, subscribe if you have not already, and tell me below what single space mission you think deserves way more attention than it gets. Now let's talk about another reason this mission feels almost unbearably precious. There is no true replacement out there doing what Voyager 2 does. That point is easy to miss because space agencies announce concepts all the time. There are always ideas for future probes, future outer planet missions, future interstellar studies. But ideas are not spacecraft. A concept on paper cannot send back measurements from beyond the heliopause. Right now, at this exact moment, Voyager 2 and its twin are the only human-made objects operating in interstellar space. Once they go silent, humanity loses its direct physical presence there. That does not mean science stops. Telescopes will keep watching the universe. Models will improve. New missions will study the sun, planets, dust, magnetic fields, and radiation from other positions. But it does mean something specific will vanish. We will no longer have a machine that is physically out there sampling the local interstellar environment from within it. And building a successor is not simple. Even if an interstellar probe were fully funded tomorrow, it would still take years to design, build, test, launch, and then decades to travel, far enough to take up Voyager's role in any comparable way. Space is not hard only because of distance. It is hard because every step takes patience on the scale of generations. So, yes, Voyager 2 is old, but old here does not mean outdated in the normal sense. It means irreplaceable. That word should sit with you for a second. Irreplaceable. Because this spacecraft is not just an icon of the past. It is an active observer in a place we currently cannot revisit on demand. When it measures plasma waves and magnetic fields out there, it is giving us direct data from a region we cannot simulate perfectly, touch ourselves, or inspect with newer tools simply because we want to. There is another emotional layer too, and it might be the deepest one of all. Voyager 2 is carrying the golden record. Long before anyone knew how long the mission would last, engineers and scientists attached a message for the cosmos. Greetings in many languages, sounds from Earth, music, images encoded onto a physical record, instructions etched onto the cover so that, in theory, another intelligence could figure out how to play it. People often mention the golden record as a charming detail, almost like a footnote. It is more than that. It changes the emotional meaning of Voyager. Because the spacecraft is not only a scientific instrument, it is also a statement, a small piece of humanity launched into the dark with no guarantee anyone will ever find it. Think about the confidence and humility mixed together in that decision. Confidence, because humans believed they had something worth sending. Humility, because they knew the chances of a reply were tiny. The record was never a practical communication plan. It was a gesture, a bottle thrown into the largest ocean imaginable. And one day, when the power finally runs too low, Voyager 2 will stop talking, but it will not stop traveling. It will continue drifting through the galaxy in silence, carrying that record long after every person alive today is gone. In that sense, the mission has two endings. One is technical, when the radio falls quiet. The other never really ends at all. There is something haunting about that. A machine built before the internet age, before smartphones, before most of modern digital life, still moving outward forever, with our music, our greetings, and our image of ourselves locked inside it. Now let's come back to the title of this video, because it is important to say this clearly. The unexpected data from Voyager 2 is not some fake alien code or dramatic secret signal. The real surprise is scientific, and in many ways that is far more meaningful. NASA's own findings show that the boundary around our solar system is more complex than many expected. The magnetic field result was surprising. The plasma compression was surprising. The warmth and density behavior were surprising. The apparent leakiness of the heliopause was surprising. And together, those details tell us that even at the edge of our own neighborhood, reality is still richer than our diagrams. That matters for another reason. Science is often presented as if discovery only happens when something flashy explodes into the news. But Voyager 2 reminds us that some of the biggest discoveries arrive quietly. A line on a graph shifts, a field points in the wrong direction, a density rises where it should not, a model becomes less certain, and suddenly the universe is bigger than it was yesterday. That is what deep exploration really looks like. It is also worth appreciating the people still behind this mission. Most of the engineers working on Voyager now were not there in 1977. Many were not even alive then. They inherited an artifact from another era and learned how to keep it going. They study old systems, improvise around failing margins, and make careful decisions about which parts of a nearly 50-year-old spacecraft deserve the last precious watts. That is not glamorous work in the normal media sense, but it is extraordinary. It is a relay race across generations. One team launched the mission, another kept it healthy through the planetary encounters, another guided it to the heliopause, and another is now shepherding it through its final scientific chapter. Final stretch of this journey together. If Voyager 2 earns your respect, let this video earn your sub. Drop a like, subscribe for the next chapter, and send this to that one person who still believes science stories can feel personal. So what happens when the last signal finally comes? Probably nothing dramatic. No movie speech, no goodbye from the stars, no sudden burst of poetic final words from the spacecraft. The power will simply fall below what is needed to keep the transmitter working, and one day a signal that has been arriving for nearly half a century will stop. That is all, and that is enormous. Because silence from Voyager 2 will not just be the end of a machine, it will mark the end of a living conversation between Earth and one of the most distant objects we have ever built. A conversation carried on across nearly 20 hours of light travel time. A conversation that survived planetary flybys, system glitches, shrinking power, and the death of the Cold War world that created it. There is a tendency to think of great exploration as something dramatic and loud. Rockets roaring, flags waving, big speeches. But a lot of real exploration sounds like this instead. A weak signal, a patient team, and a string of numbers that slowly changes what we think we know. Voyager 2 has spent decades turning invisible regions into measured reality. It helped reveal the giant planets as places, not just points of light. It showed that Uranus and Neptune were stranger than many expected. It crossed into interstellar space and proved that the edge of the heliosphere is not a simple border. It kept going long. past its design life. And even now in old age, it continues to teach us that nature does not owe us simplicity. That may be the most beautiful part of the entire story. Even as Voyager 2 loses power, it is still producing knowledge. Even while parts of it are being shut down to conserve energy, it is still telling us the universe is more subtle than our assumptions. Even near the end, it is still doing first-class exploration. There is something deeply human in that. To keep going, to keep sending meaning home, to keep revealing truth, even when the light is fading. And maybe that is why so many people feel emotional when they hear about Voyager now. Because the mission is no longer just a triumph of engineering. It feels like a mirror. It shows us what endurance looks like, what long-term thinking looks like, what it means to build something not for immediate reward, but for knowledge that may mature across half a century. In an age obsessed with speed, Voyager is slow. In an age obsessed with upgrades, Voyager is ancient. In an age obsessed with noise, Voyager is quiet. And yet it remains one of the most powerful symbols of what our species can do when curiosity is stronger than convenience. So, yes, NASA confirmed that Voyager 2 sent back data scientists did not fully expect. But maybe the deeper truth is this. Voyager 2 keeps reminding us that the universe still has the power to surprise us, even right at the edge of home, and even through a machine built almost 50 years ago. One day that signal will stop. But until it does, every new reading from Voyager 2 is more than data. It is a message from the frontier. A thin, patient whisper from a place no human has ever seen with their own eyes, telling us that the border of our world is stranger, more porous, more alive, and more beautiful than we imagined. And when that final silence eventually comes, what will remain is not just the record of a spacecraft. It will be proof that humanity once built a machine, sent it into the dark, kept listening for nearly half a century, and learned that even the farthest edges of our reach were still only the beginning.